Good afternoon, everybody, and welcome to another Chem practice problem lesson day. Today, due to popular request, I've actually pulled up a bunch of titration practice problem questions, and we will be working on those titration practice problems questions today. Here's just a reminder to everybody that you have a test due tomorrow by 11:59. So please make sure you get a chance to do that. It is timed, so as soon as you open the assignment, you have 50 minutes without pausing to complete your assignment. And that's it. Let's do some practice problems. First practice problem here says in a titration, 5 milliliters of a 2 molar NaOH solution exactly neutralizes 10 milliliters of an HCl solution. What is the concentration of the HCl solution? Right. Here they tell you titration, they tell you neutralize. Right, you know you're dealing with acids and bases. They specifically tell you titration this time. So you, right off the bat, can know that MAVA equals MBVB taken right off of table T. You're going to plug in your information. You know 2 molar base. You know 5 milliliters of base. You know 10 milliliters, of acid. And you do not know the molarity of the acid. Right, so solving your way through this, 10 molarity times milliliter equals 10 milliliters. X divided by 10 milliliters. Cancel, 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 cancel. X equals 1 molar. Right. Questions, comments, concerns there? The topics covered on tomorrow's test is everything from acids and bases. Moving forward. In a titration, 20 milliliters of a 0.15 molar NaOH solution exactly neutralizes 24 milliliters of an HCl solution. What's the concentration of the HCl solution? So again, they're telling you it is a titration, so you know right off the bat, MAVA equals MBVB, which means you can start plugging in your pieces. They give you 20 milliliters of base. They give you 0.15 molarity. They give you 24 milliliters. And they're asking you to solve here. Right, so doing your math out, you're going to do your division by 24 milliliters. Right, cancel, 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 cancel. When you do the math out, you should get A as your answer. 0.15 times 20 over 24. Right. When you just plug all 3 of these things into your calculator, you do get A as your answer. Capital M. Right, so remember that if they're giving you actual problems, right, if they're giving you actual chemicals here, you have 2 pieces of the reference table that can help you out, right, on top of the fact that they're telling you it's a titration. The identity of these chemicals does matter. It matters because we could have NaOH, we could have CaOH2, or we could have AlOH3, right? And each one of these things, like we've talked about in the past, gives you a different amount of OHs. So that would affect your calculations in a little bit of a different way. Same thing goes with the HCl. You can have HCl, you can have H2SO4, you can have H3PO4, and each one of these things gives you a different number of H's. And when we're doing a titration or a neutralization, right, it matters that the OHs match up with the H's. So if you have one aluminum hydroxide, you're going to need 3 HCl's to cancel those out. If you have 2 calcium hydroxides, that's 4 OHs, you're going to need 1 1/3 H3PO4s to cancel that out. So it will affect the math a little bit. Here, the identity matters only in the fact that we can confirm that it's 1 OH and 1 H. We don't need to do any adjustments. But let's say, for the sake of argument, that this wasn't NaOH, this was CaOH2. Right, which doesn't look great when I write it in the margins like that. Let's put it here instead. Right, if this is the question now, when we want to solve this out, we're still going to use MAVA equals MBVB. But when we plug in, we have X 24 milliliters, 20 milliliters. And then here, instead of plugging in 0.15, we would plug in 0.3. We would double this number because we have twice as many OHs. All right, 1 CaOH2 gives you 2 OHs. So we're checking the molarity of OH. It's double the molarity of calcium hydroxide. And then we would solve out accordingly. Is this one of the things they expected you to do? Hold, right? So if I did 0.3 times 20, it would give you 0.25 as your answer, right? Right, which isn't the right answer to the actual printed question, but would be the right answer if this was calcium hydroxide. Question about the test here. The test is all the topics from acids and bases. Everything in the first 4 videos of our acid-base unit is going to be covered on that test. Can you take the test tomorrow? You can take the test today. You could have taken the test yesterday. You can take it anytime, as long as you have 50 minutes to sit and take the test. It will automatically submit just like your Test Wizard homeworks. So it's due tomorrow at 11:59. So make sure you sit down for 50 minutes before tomorrow at 11:59. There are 21 questions on the test, 19 multiple choice and 2 short answer. And then I'm going to get around to grading it Friday morning, and we'll go over it Friday this time. Friday. You'll get your answers Friday. They will release at midnight tomorrow, right? 12:01 a.m. on Friday. All right, moving on to another question here. What volume of 2 molar NaOH is needed to completely neutralize 24 milliliters of 1 molar HCl? Here they don't tell you if it's a titration, but they do say neutralize. So that means we need to make sure that moles of acid and moles of base are equal. If we look at the pieces that they give us a molarity, a second molarity, a volume, and they ask us for a volume. All right, so this is all the pieces we need, to plug in to our equation. Right, we can say that 1 molar times 24 equals 2 molar times X, giving us B as our answer. Questions, comments, concerns there? Alright, moving. So volume and yeah, so if they're giving you molarity and volume, and they're giving you, right, basically if they're giving you 3 of these 4 pieces, you can solve this equation. If they're talking about neutralizing, if they're talking about a titration, and not necessarily, right? Because this question doesn't ask you about titration at all, right? It doesn't say the word titration in it anywhere. So just because it doesn't say titration doesn't mean it's not a titration problem, because this is the titration equation. Right? If they say the word neutralize and they give you the pieces that you can plug in, then plug in. If they don't give you these pieces, then you have to take a step back and say, nope, that's not what I want to do. You will have to say moles of H plus equals moles of OH minus, and take a step back from this, which is very specific, to this, which was just neutralization. It doesn't matter what your units are for volume as long as they are the same on both sides. Right, so let's say, for example, this said 12 liters. Right, 12 is the right mathematical answer, but milliliters is the right unit. Right, so if we're going to solve this out, right, 12 liters is definitely not the right answer. 12 milliliters is the right answer. The units that are going to cancel out. So if they're giving you 2 volumes, as long as they're the same unit, you can plug them in. What would a molarity question look like? Well, I just did 2 of them, so let's see. Alright, this one that we just did was a molarity question. This one that we did before was a molarity question. It just depends on what they're asking you for. The questions look the same. They're giving you 3 of your 4 pieces, and they're asking you to find the 4th. Here on the other one, they're giving you 3 of your 4 pieces and asking you to find the 4th. Here in the one we just looked at, they're giving you 3 of your 4 pieces and asking you to find the 4th. If we look at another one, which volume of 0.1 molar sodium hydroxide neutralizes 15 milliliters of 0.2 molar HNO3? Again, 3 of the 4 pieces they have given you. We plug all our pieces in. When you solve this out, you get, what do you get? 3 as an answer, 30 as an answer. I've got a couple more. I think I have up to 28, so I got 3 more of these neutralization math practice problems, and then I will give you a pH problem, yes. A student neutralizes 16.4 milliliters by adding 12.7 of 0.62 molar KOH. What's the molarity, right? So again, we see 3 of our 4 pieces. We look and label each of them appropriately. HCl is an acid, so this is the volume of our acid. 12.7 milliliters of 0.62 molar KOH. These are both the pieces of our base. They're asking us to solve here, which I can't do in my head, so I need a calculator for. Right, plugging them in gives us x equals 0.480. Samantha, I'll get to that after I do a pH problem in a little bit. Right, again, 2 more of these, and then we'll break into other things. 50 milliliters of an HNO3 solution is exactly neutralized, keyword neutralized, by 150 milliliters of 0.5 molar solution of KOH. So again, 3 of our 4 pieces, and they're asking us to solve for our 4th, right? They're asking us to solve for that. They say 50 milliliters. They give us 150 and 0.5. Divide by 50. Gives us 1.5 is our answer here. All right, last one of these kinds of problems before we go forward. If 5 milliliters of 0.2 is neutralized exactly, neutralize, keyword. Again, it's MAVA equals MBVB. 5 milliliters of acid, 0.2 molar acid, 10 milliliters of base. Plugging our way through to solve. 0.1 is going to be our answer. Right, so notice the pattern in these mathematical questions. We have 3 of the 4 pieces. They say the word neutralize, or they straight up say the word titration. They're giving you 2 milliliters and a molarity, or 2 molarities and a milliliter, and asking you to solve for the missing piece. Is OH an ion? Yes, OH is an ion. Right, OH minus is a hydroxide ion. Alright, table E tells us that. along with the other polyatomic ions. Right, so now answering 100 other questions. Let's get a blank slide in here. For us to write on. Alright, so I was asked about a pH practice problem. I was asked about a molarity practice problem. I'm asked about an acid. What do you mean an acid-base problem? Every problem we've done is an acid-base problem. You mean the definition of acid and base? Can you be a little bit more specific? Okay. So a pH practice problem would be something like so if this is a problem, they're asking me to find the pH of these solutions. First, if it's going to have a pH of 5, we can narrow down our choices because it has to be an acid. KOH is a base, so it's not going to be KOH. NaOH is a base, so it's not going to be NaOH. And then we're left with these two choices. In order to solve this out, you have to put these into scientific notation. Moving my decimal 1, 2, 3, 4 spots makes this 1 times 10 to the negative 4 molar HCl, which means this has a pH of 4. Moving this 1, 2, 3, 4, 5, 1 times 10 to the negative 5th molar HNO3 means this has a pH of 5. They're asking me for 5. That is my answer. Right? It's just knowing that when you put the concentration of an acid into scientific notation, this number is your pH. Right, and it has to be an acid. It has to have that H+. Questions, comments, concerns there? we can do another pH problem, sure. Nope, not what I want to do. Come back here. There you go. No, those two types of problems are not the majority of questions on the test. There is no majority of questions on the test. I'm trying my best to just do problems that people are asking for. All of the topics that we have covered have my best shot at a fair representation on the test. Alright, so here's one that works in our reference table M into the picture. Alright, remember table M is our indicator table. And on that table it tells me that methyl orange from 3.1 to 4.4 changes from red to yellow, right? Which means that if we want it to be red, it has to be less than 3.1 pH. Right, so we're looking at these choices and trying to get them into a pH of 3.1. pH of less than 3.1 means that it has to be an acid. So again, that's going to help narrow down that it's definitely not going to be these two bases over here. Then we're going to put these 1 times 10 to the negative 1. Giving me A is my answer. Is the hydrogen ion concentration of a solution typically a tenth of the pH? No. That's not the way the math works out. You're on the right track, Leah, but that's not mathematically how it all fits together. So let's walk through that again. Erase holding on the slide. So when we look at pH, nope, not highlighter. I just want black ink for a pen. How did we go back to red ink? I just turned it black. There we go. If we look at pH, and we want to work backwards from here, and we want to compare the hydrogen ion concentration. Sorry, my sound totally was off. I muted my mic and then never unmuted it, even though I clicked the button. It's not a tenth. Right? I gotcha. It's not a tenth. It's not a relationship of the pH is a tenth of the concentration. Because then if that was the case, this would just be 0.2, this would just be 0.3, and this would just be 0.4. But that's not the way the numbers play out. The pH scale works on factors of 10. So saying not that it's a tenth. Is my sound still off? Check, check, check. Tap, tap, tap. Tap, tap, tap. It says my sound is on. Okay, great. Perfect. So changing the pH is not a tenth, it's factors of 10. Right? So going from pH of 1 to a pH of 3 is 100 times less H+. Right? 2 steps is 10 times 10, 100 times less acidic. Right? And then if you go the opposite way, if I go from a pH of 4 to a pH of 3, right, 1 step is 10 times, going down is more acidic. Right? pH scale is a factor of 10 scale, so it's not just saying that this is a tenth, it's 1 times 10 to the negative 3, 1 times 10 to the negative 4, right? Because each one of these, this is 10 times less. And then if we look at this one, this is 10 times less. And then if we look at this one, this is 10 times less. Right. One more before we switch into tutoring and office hours was a acid-base definition question. No, a molarity question. Sorry. And then we'll go into acid-base definition in tutoring and office hours. What number of moles of HCl are needed to neutralize 3 liters of 0.5 molar NaOH? If I want to solve this out, right, it looks like a titration, right, because they give me a volume, they give me a molarity, but they only give me 2 instead of 3 of the pieces that I need. So this would just be using the molarity equation. We know that moles of H plus need to equal moles of OH minus. I know that moles of H plus are going to come from my molarity equation. They gave me molarity. They gave me liters. Solving for moles, 1.5 moles of H plus means 1.5 moles of OH minus means 1.5 moles of NaOH. Right. I'm going to transition us into tutoring and office hours. I know I didn't answer your question, Gloria, but we will do that in tutoring if you stick around. Tomorrow there is tutoring and practice at 1, right? So that's mostly if you have anything else you want to go over, bring it there and we will talk about it. Remember that your test is due tomorrow at 11:59. Right? Transitioning us over to tutoring and office hours. Check back here in a second. Have a fantastic day.